In this screencast, we're going to tackle one of the more challenging aspects of this chapter, which is converting between different concentration units. So in this graphic, you can see in the left side, we have a 1 molar solution of glucose, and on the right-hand side, we have a 1 mol solution of glucose. And so we want to remember that molarity is moles per liter, per 1 liter of solution. And so when we're talking about the solution, we have the solute plus the solvent, whereas molality is going to be moles per 1 kilogram of solvent. So we're looking at two different things. So sometimes the challenge becomes, how do I convert between a molality for a solution and a molarity? And one of the factors that you will have to remember as we go through this process is density, because sometimes density of the substance is required in order to make these conversions. So you want to remember that density is grams per milliliter for whatever substance you're dealing with. You would not need to memorize these for the test other than knowing that water is 1 gram per 1 milliliter. Otherwise, they would be given to you, but just be aware of the fact that there are times when you are going to need to look at the density in order to determine what's going on. In this sample problem, we are asked to calculate the mass percent, parts per million, and mole fraction for a solution of acetic acid that has a molality of 3.5 mol. So we're looking for three things: mass percent, parts per million, and mole fraction. We're told that we're dealing with acetic acid, and we're given the molality of 3.5. So what we need to do, first of all, is we need to recognize that when we're dealing with a 3.5 mol solution, what that's really saying is that I have 3.5 moles of acetic acid, that's the HC2H3O2, per 1 kilogram of solvent. And we can assume that the solvent is going to be water. So from this information, I can go ahead and I can calculate the mass of my solute and the mass of my solvent. So for my solute, okay, I have 3.5 moles of acetic acid. I'm going to divide that by 1 mole and multiply it by the molar mass of acetic acid, which is 60 grams. And that will give me 210 grams of my solute. 1 kilogram of water is going to be equal to 1,000 grams of water. So now I'm looking at my solvent, and I have 1,000 grams of water, and if I want to find moles, I divide that by the molar mass of water, which is 18 grams on the bottom, 1 mole on top, and when I do that, I end up with 55.56 moles of water. So now the first thing I was asked to find was mass percent. So the mass percent of acetic acid, and I know my solute, acetic acid, I had 210 grams. And for the mass percent, I'm going to divide it by the mass of the solution. So that means I need to take my solute, which is 210 grams, and add it to my solvent, which was 1,000 grams. I'm going to multiply by 100 to make that a percent. And when I do the math, I get 17.36%. My second problem asked me to find my parts per million. So it's very similar to number 1. I take my 210 grams of my solute. I'm going to divide it by the total mass of my solvent, which is the 1,210 grams. I multiply it by my factor of 10 to the 6 because I'm doing parts per million, and I end up with 173,554 parts per million of my solute. Now for my mole fraction, I'm going to actually move over here to the bottom, but I can do that for both my solute and my solvent. My mole fraction for H2O, which is my solvent, is going to be my 55.56 moles divided by 55.56 moles plus my 3.5 moles. And when I do that, I end up with 0.941 as my mole fraction for water. I can also do my mole fraction for the acetic acid. And that's going to be my moles of acetic acid divided by my total moles, or I can just take 1 minus my 0.941 because we know that the sum of the mole fractions is going to total 1, and I would get 0.052. 9. So here are some of my hints to help you with converting between units. First, make sure that you are identifying the starting amount using terms like solute, solvent, and solution. Make sure you know your concentration units, and I mean all of them, from percent mass and percent volume, to parts per million and parts per billion, mole fraction, molarity, and molality. Make sure you solve for moles and grams of both the solute and the solvent. And don't forget about your density conversions, because that will let you go from mass to volume and also from volume to mass. These hints will help you as you're doing your conversions between units for concentration. Good luck.